Hey guys, I wanted to do a video on how to use the law of sines for SSA triangles, which are side-side angle triangles, meaning you're given two sides and one angle. Alright, so here is our sample problem. I am given angle B is 117 degrees, side B is 16, and A is 38. So first things first, I'm just going to draw my triangle. I get a visual of what I'm working with. It's not a right triangle, even though that one might look like it. I label this A, B, and C. This must be side A, side B, and side C. I know that this is 117 degrees. And I also know that this has a length of 16 and this has a length of 38. So I'm also going to plug them in over here on my little chart to help me keep track of what I'm looking for. I'm given that this is 117 degrees. I'm also given that this side is 38 and that this side is 16. Because this is not a right triangle, we cannot use the Pythagorean theorem. What I'm going to look for first is angle A. I have side A, and I also have this pair of side B and angle B. So, since I'm solving for an angle, I'm going to write my law of sines angles up. So, sine of angle A divided by A is going to equal my knowns that I have. I'm going to use this pair, angle B and side B. So sine of angle B over B. So plugging in what I know that I don't know what angle A is, but I do know that side A is 38. Angle A is 117 degrees. And side B is 16. In order to get, or one step in order for us to get this A by itself is to get rid of this denominator. So what I'm going to do is multiply both sides by 38. That way these two cancel out and leave me with sine of A that equals sine of 117 degrees divided by 16 times 38. It would be great if we were done. However, I'm looking for angle A, not sine of A. So I got to find a way to get rid of this function sine. Well, I know one thing that cancels out a function is its inverse. So I'm going to take the inverse of sine to get rid of this sine so I can get A by itself. However, what I do to one side, I need to also do to the other. And this is where we just have to make sure that we're getting, I don't like the way that looks, that we're being very specific on how we're putting this into our calculator. Having issues. Alright, so these two cancel. So all I'm going to do is put all of this into my calculator, and I get that angle A simply equals 22 degrees. So it's no longer unknown. I know that it's 22 degrees. Well, now that I know what angle A is and what angle B is, I can figure out what angle C is by using the triangle sum theorem. And the triangle sum theorem tells me that angle A plus angle B plus angle C should equal 180 degrees. So I'm going to take the 180 degrees and I'm going to subtract off the other 2 degrees. So I'm going to subtract off 22 and subtract 117. The difference should be my missing angle, which is 41 degrees. So I'm going to plug that right there. So at this point I'm happy because I'm almost done. I know that angle B is 117. Angle A is 22, angle C is 41, And it'd be nice if I knew what side C was. It's the last thing that we need to find. So, since I'm looking for a side, I'm going to write my law of sines with sides up. So, side C of sine of C is going to equal, doesn't matter which one we use, why not? Let's use B. Side B of sine of B. So let's plug in what I know so I can solve for what I don't know. I don't know what side C is, but I do know that angle C is 41 degrees. I also know that side B is 16 and that angle B is 117. In order for me to get the C by itself, I need to multiply by this denominator because that will cause them to cancel out. However, what I do to one side, I need to make sure that I do to the other side. 41 degrees. This works out so that those two cancel out. So all I have to do is put 16 divided by sine of 117 degrees and multiply that by sine of 41 degrees, my calculator, and I would get that side C is simply 28. And we have solved this triangle.